Okay, so we've got a probability question here, and I think the easiest way for us to approach this is to write out some of the details of the problem, just so we can help visualize it, and then we'll make a decision tree. So let's start with that. Let me just share my screen. Okay. All right. So start off here. We have 20 pens and 2 are defective. So that means that we have 18 pens that are good and we have 2 pens that are bad. I'll just write it like that. And we have some buyer who's going to inspect 5 pens at random. And so we'll just write that down. So 5 inspect. And if he finds even one of these is defective, then the buyer's just going to walk away. Yep. So what's the probability that the buyer will purchase? So the probability that the buyer is going to purchase is just the same as the probability that he inspects 5 pens and they're all good. So keep that in mind. If the buyer finds even one of these pens is bad, the buyer's not going to buy it. So they all have to be good. So let's start writing out a tree here. At the top, we have our 20 pens. We have 18 good, and we have 2 bad. And the buyer could go either way here. In one situation, the buyer chooses a good pen. In the other, the buyer chooses a bad pen. So the probability that he chooses a good pen is what? So we have 18 good and 2 bad. So the probability is going to be 18 over 20. The probability of the bad choice is going to be 2 over 20. And if we go this way, we're left with now 17 good, since he just took one, and 2 bad. And if we go this way, we're left with 18 good and 1 bad. But this doesn't really matter. This part of the tree, it's going to continue down, but the buyer's going to get this bad pen and he's just going to walk away. So we don't even have to worry about these probabilities anymore. So let's continue on the other half of the tree. So again, the buyer has the same choice. He could pick a good pen or he could pick a bad pen. And the probability that he picks a good pen is 17, since we have 17 good, over 19. Because now we have 19 pens. And what's the probability that the buyer picks a defective pen? It's going to be 2 over 19. So again, we don't need to worry about this part of the tree anymore, because as soon as the buyer picks a defective pen, the buyer's going to walk away. So we're just going to focus over here. And now, let me just change the color again. I'm playing around with the colors today. So we have 16 good, since the buyer just took one, and we still have our 2 bad ones. So as you see, our buyer did the first test and it was positive. Second test, it's positive. This is going to continue down 3 more times. And to avoid writing all that out and to save us some time, let's identify a pattern here. The first time is going to be 18 over 20. The second time, it's going to be 17 over 19. The third time, it's going to be 16 over 18, right? Because every time we're losing one of our good pens and we're losing one from our total as well. So to calculate the probability, we're going to have this probability times this probability times that probability times 2 more probabilities, which I'll let you calculate, but following this pattern, I think you should be able to figure that out. Let me stop sharing. Okay, so I hope that clears it up. It's kind of a fun problem, a little tricky. So if you have any questions, just leave a comment and I'll try to answer it as soon as I can.